All right, this is lesson 7.5, proportions in triangles. We're going to learn a new theorem called the side splitter theorem and also the triangle angle bisector theorem and how to use those. You can pause here if you want to try the review. All right, if a line is parallel to one side of the triangle intersects the other two sides, then it divides those sides proportionally. This is known as the side splitter theorem. So what we have here is if RS is parallel to XY, so here's our two parallel lines, then XR, this little piece, to RQ, this piece, is equal to the ratio of the corresponding sides on the other side of the triangle. So SY and SQ. So if XR is 4 and RQ is 4, and we know YS is 5, then the ratio of this side, which is 4 over 4 is 1, has to equal the ratio of this side, which would be 5 over 5. Or if RX is 3 and RQ is 6, then the ratio of those two sides is 1/2. If YS is 4, then to get 1/2, we would have to have 8 for SQ. And then the corollary to that theorem is if three parallel lines intersect two transversals, then the segments intercepted on the transversals are proportional. So if A is parallel to B is parallel to C, then AB over BC, so this over this, is equal to WX over that. Okay, they're not congruent. Sorry about those congruent marks, but the ratios of the two sides are the same. So, complete each proportion. All right, so here's how you use that side splitter theorem. What is the value of x in the diagram? Since we see these two lines are parallel, we can say that the ratio of this to that is equal to the ratio of this to that. So, and that's the side splitter theorem. So 4x minus 2 over 9, that has to equal 3x plus 2 over 12. And that's the side splitter theorem. At work, and then using cross products property, we can say that 12 times 4x minus 2 is equal to 9 times quantity 3x plus 2. And that's the cross products property. And using the distributive property, we can say 48x minus 24 is equal to 27x plus 18. And then using some properties of equality, we can continue to solve this. Subtract 27 from both sides, and that gives us 21x minus 24 equals 18. Add 24 to both sides, and we get 21x equals 42. Divide both sides by 21, and we get x is equal to 2. And just to check that, so if x is 2, 4 times 2 would be 8, minus 2 is 6. So we get 6 over 9. And then 3 times 2 is 6, plus 2 is 8. We get 8 over 12. We have to make sure those are equal. 6 times 12 is 72, and 9 times 8 is 72. So if the cross products are equals, then they're proportional. All right. You can go ahead and do this and check back with your answers. All right, those are the reasons you should get. So, finding the length. Two plots of land are shown below. What is the unknown length x? All right. This looks like a place we can use the corollary to the side splitter theorem. We have three parallel lines cut by two transversals, so we can use the idea that on this side, those two lengths, the ratio of those two lengths will be proportional to the ratio of those two lengths on the other side. So we can say 56 over 70 is equal to 62 over x. And that's the corollary to the side splitter theorem. So let's say side splitter theorem corollary. And then using cross products property, we can say 56x is equal to 70 times 62, which is 4,340. And we can divide both sides by 56, and we get x is equal to 77.5. So 77.5 right here. All right, go ahead, you try, check back with your answers. All right, another theorem we have is the kind of a related thing here, triangle angle bisector theorem. If a ray bisects an angle of a triangle, then it divides the opposite side into two segments that are proportional to the other two sides of the triangle. So if AD bisects angle CAB, then CD, this one, the ratio of that to the other part that is cut off is equal to AC over BA. So let's put that to work here. So we know that this is the angle bisector because both these angles are the same. So that means that I can write this as a ratio to that, 9 over 15. And that'll be proportional to the other two sides of the triangle, x and 25. And that is from the triangle angle bisector theorem. All right, and then using cross products property, we can say 15x is equal to 9 times 25, which is 225. And that is using cross products property. Divide both sides by 15, and we get x is equal to 15, using the division function of equality. All right, go ahead and you try that. And the lesson check, circle the proportion you can use to solve the problem. So we have the side splitter theorem going on here. And is the first one through 10 over 30, that over that, is that proportional to x over the whole side length? I don't think so. How about x over 10, the short piece to the long piece, is that the same as 30 over 45? No, it would be 15 over 45, or 15 over 30, I mean, this little part here, but so we don't have that. Do we have x over x plus 10, so this short side to the whole side, is that equal to the long side to the whole side? I don't think so. 10 over x plus 10, so this long side to the whole side, is that the same as 30 over 45? Yes. So then we are going to do cross product property, and we're going to say 45 times 10 is equal to 30 times x plus 10. I think I'll divide both sides by 30, and that gives me, this is 450 divided by 30. That gives me 15 is equal to x plus 10, and then I can see that x is equal to 5. All right, one more lesson check. Classmate says you can use side splitter theorem to find both x and y. In the diagram, explain what is wrong with your classmate's statement. Cross out the lengths that are not part of the sides intersected by the parallel line. So 7 is not part of that, neither is x. The rest of them are because there's 4 parts there. Can you use the side splitter theorem to find x? No. Can you use side splitter theorem to find y? Yes. And the reason my classmate is wrong is because x is not part of the side intersected by the parallel line. All right, that's it. See you tomorrow.